Hello, Econ 150 students. This week we're looking at chapters 12 and 21, dealing with the concept of monopoly and antitrust. So the first question here asks us to see the structure of a monopoly. A pure monopolist is faced with some cost data and some revenue data. So our job is to answer part B and C. What is the profit maximizing price and output, and what will the monopolist profit be? So this is going to be one of those multi-part problems where we're going to want to make sure we know each step of the process and we go through it. So we're going to start with calculating the missing information in this chart, total revenue and marginal revenue amount. So the cost information is given us. Our total revenue is price times quantity. That's our calculation for total revenue. So we can pretty quickly see how this is going to go. 100 times 1, 83 times 2, and so on. And you have the values there in front of you, and I'm just going to run down what those are. 83 times 2, and so on and so forth. Sorry, just make sure I got all this. 166, 71 times 3, 213, 252, and so on. So I'm actually going to only go that far. Marginal revenue is the change in total revenue in relation to the change in output. And in this case, the total products is changing by 1 each time. So we don't have to do the calculation there. We can just take the change in total revenue. So for that first unit, marginal revenue is 100. For the next one, it's an additional 66, 47, 39, 23, and so on. Now we're asked about what is the profit maximizing price. So what we're looking for is profit maximizing is MR equals MC. Whenever you see marginal, by the way, it's a how much decision. So the profit maximizing price is going to be at that correct quantity that maximizes profit. And we've been talking about that. So we're going to actually start with the output to understand this. So we have marginal revenue, our calculations right here, on our marginal costs here. And we can kind of do the comparisons. 100 is greater than 45, so yes, continue. 66 is greater than 40. 47 is greater than 35. 39 is greater than 90, or 30, excuse me. But 23 is less than 35. So as we're making these comparisons, we can see that this would be the point where we'd stop. We would not produce that fifth unit, or the monopolist wouldn't, because the marginal cost is greater than the marginal revenue. So what that tells us is that the profit maximizing output then will be 4 units of output. So we can put that in first. The profit maximizing price then will be what the price is at those 4 units of output, and we can find that right here. So that is $63. And the monopolist profit for producing those 4 units can be calculated by taking the average total cost. So we can take 5250 times those 4 units, and it gives us total cost. And that total cost is, I'm being a little lazy here and just looking, is $210. I don't know what I'm looking at here. And we can compare that to the total revenue for those 4 units. And total revenue is here at 252. So you subtract costs from revenue. That's our formula for profit. And we're going to get the monopolist profit at $42. So this is one of those problems that asks you to know a few things and start at the beginning and work your way through. But if you're comfortable with each of those processes, you're going to be a lot better off to doing these calculations. So my advice would be practice it, try a few versions of it, and just make sure you're totally understanding the process by which the answer was gained. So number 2 brings us the output decision and the cost of a monopoly firm. It says that the most efficient production technology available for making vitamin pills has the cost structure we see below. And the output is measured as the number of bottles of vitamins produced per day, and that costs include a normal profit. Remember that normal profit is what we'd refer to as zero economic profit or breaking even. It's where the total costs, including implicit costs, so explicit plus implicit costs, are equal to revenue. So here we have the data, and we're just going to take the information we have and calculate average total cost. So average total cost is total cost divided by output, or quantity in this case. So I'm just going to take 100,000 total cost for that first one divided by 25,000, and it tells me that it's $4. And continuing on, I'm going to do the same thing, total cost divided by output. So for the next one, I can see that's $3. Then we have $2.50. Then we have $2.76. So that's the first step that's important because we're going to be asked to evaluate that. B says, is this a decreasing cost industry? The answer is no, and the reason we can say no is because it doesn't decrease at every output level. So it does decrease here, 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 but then we have an increase. So we can, by definition, say no, this is not decreasing cost. Part C, suppose that a market price is $2.50, and at that price, total market quantity demanded is 75 million bottles. How many firms will this be? So we're going to come up here to our information. $2.50, if that's the market price, then each firm at that market price would be willing to produce, right, because that's marginal cost equal to marginal revenue, which would be the market price. They're going to produce 75,000 bottles for each individual firm. So here we're going to take the 75 million bottles that the industry demands, divide it by the 75,000 that one firm would provide, and we're going to say this must mean then in this situation, there would be 1,000 firms. Suppose instead that the market quantity demanded at that same price, $2.50, is only 75,000. How many firms would there be in the industry? And pretty quickly you see, well, at $2.50, one firm is going to produce 75,000. Therefore, we could say that's one firm. Part E, review your answers to Part B, C, and D. And does the level of demand determine the industry's market structure? And clearly the answer is yes, 1,000 firms versus one firm. And that is not a change in price, that is a change in the quantity demanded at that price. And so this is going to be a clear yes. Number 3, suppose you've been tasked with regulating a single monopoly that sells 50-pound bags of concrete. The firm has fixed costs of $10 million per year and a variable cost of $1 per bag, no matter how many bags are produced. So right off the bat, we have some good information to work with. And it says, if this firm kept on increasing its output level, would ATC per bag ever decrease? And the answer is no. ATC would never decrease. It would increase at a decreasing rate. And here's why. Because we've got average total cost is average variable cost plus average fixed cost. That's our total. That's our definition. And as we're producing more units, the average fixed cost is spread over more units of production. So that's going to bring it down. Remember, average fixed cost is our asymptote. So it's going to constantly be decreasing the amount of average variable cost at a pretty steady rate. So if we were looking at this, would the average cost per bag ever increase? No, because of that drag of the AFC. And what we can see about this is this defines for us a decreasing cost industry. So by definition, because again, that spreading effect of the average fixed cost. If you wish to regulate this monopoly by charging the socially optimal price, what price would you charge? So socially optimal, by definition, is where demand is equal to marginal cost. So we already know our marginal cost from the information given us, and that is $1 per bag. So fixed costs are 10 million. Marginal is $1 per bag, no matter how many bags are produced. So if we were going to regulate at socially optimal, we would charge that marginal cost. That means that that's as much as society wants at that price. At that price, what would be the size of the firm's profit or loss? Well, in this case, the socially optimal price would bring about a loss, and here's why. You've got $1 per unit covers your ongoing costs, your variable costs, but it does not offset any of your fixed costs. So it's going to be a loss of your total fixed costs, which is $10 million. That's given to us at the beginning. So it's going to be a loss of 10 million because, like I said, you're only covering with that $1 of revenue the variable cost, the per unit cost of production. So there's going to be a loss of the fixed costs, that 10 million. Would the firm want to exit the industry? Yes. This is the shutdown rule because it's less than or equal to minimum variable cost, average variable cost. And so again, same explanation. It's not covering any of the fixed costs. It's not offsetting any of it. C, you find out that if you set the price at $2 per bag, consumers will demand 10 million bags. What is profit or loss going to be here? Well, we can calculate revenue and compare that to cost. So we can say, well, the revenue at $2 a bag is going to be $2 times those 10 million bags. So 20 million in revenue. And the firm's costs would be the 10 million in fixed costs plus 10 million for the $1 per bag produced. So you're going to have 20 million in costs. So the firm's profit or loss is going to be 0. If consumers instead demanded 20 million bags at a price of $2 per bag, what would the profit or loss be? We can do the same calculation. We can say $2 times 20 million is going to give us 40 million in revenue. Then our costs are going to be 10 million, those fixed costs, plus the $20 million of variable cost, $1 per bag to produce. So that's going to be 30 million in costs. So subtract the 2 and we're going to get a profit. What's left over is 10 million. E says, suppose that demand is perfectly inelastic at 20 million bags, so that consumers demand 20 million bags no matter what the price is. So what price would you charge if you want the firm to earn only a fair rate of return? So by definition, a fair rate of return is where demand is equal to the average total cost. So what we want to know, what is average total cost for producing this, and that's going to be the price to be charged. And it gives you this little hint that total cost includes normal profit. So we know that total cost incorporates all of the true costs of this. So all we have to do is calculate our average total cost, and here's what we do. For 20 million bags, we can say, okay, well, total fixed cost is 10 million, and variable cost is still that $1 per bag, so 20 million. And that gives us 30 million in average or in total costs. Divide that by 20 million bags, and that's 30,000, 20 million bags. And what you're going to get is a price of $1.50 per bag. So our total cost divided by the number of units of output gives us average total cost. And that's the value we're looking for here. Number 4 asks a few definitions about the demand curve faced by a monopolistic seller. And so the first one is, what do we know about that demand curve? And we know that it's downward sloping, whereas that facing the purely competitive firm is perfectly elastic. So we're comparing the two. So the demand curve for the monopolist is that downward sloping demand curve, whereas for the firm, for a perfectly competitive firm, that demand curve is that perfectly elastic Mr. Darp curve that we've looked at before. The demand curve facing and we'll go through the answers here, but I'll just point it out, purely competitive firm, which just said this, is perfectly elastic. Let me find the right answer. Because a purely competitive firm may sell all that it wishes at the equilibrium price. And the equilibrium, of course, comes from the marketplace. The equilibrium determined by the market of buyers and sellers. C, the pure profit maximizing monopolist output or demand curve is not. And the answer here is it's not perfectly elastic because marginal revenue is negative when demand is inelastic. So at values less than 0, let me just say this right. So marginal revenue is equal to marginal cost at values less than 0. Let me show you graphically what that looks like to kind of give you a picture of this. So here you've got your downward sloping demand curve for your monopolist. You also have marginal revenue at a value less than the price or less than demand. And the logic here is if I am a monopolist firm and I want to sell more of my product, so let's say I sell 10 units at $10. If I want to sell 12 units, I'm going to have to come up here and lower my price, not just for, some customers, but for all of my customers. So let's say I have to lower my price to $8, just to use a number here that makes sense. So what that means is I am going to have marginal revenue of $2 per unit that's going to be less than the actual price. And if we continue doing that, you can see that marginal revenue is always going to be less than the actual price. Now, this informs our demand curve for the monopolist and tells us something about what will happen when marginal revenue becomes zero. So if we extend that line and say we find a point here where marginal revenue is equal to zero when it's crossing that axis, and we can take that value up here, and what we can see is that this portion of the demand curve is what we call elastic. Remember that concept. And the portion below where marginal revenue is less than zero, it is inelastic. And if you're wondering how we can tell, we use the total revenue test. So if you remember our total revenue test, it said that if price goes up and total revenue goes down, it's elastic, and vice versa, by the way. And if price goes up and total revenue goes up, it's inelastic. Well, let's apply that here. Let's say that price goes down, just to use something that's a little more visually compelling. So let's say that price drops from 10 to 8. What will happen to total revenue? Well, at $10 times 10 units, total revenue is 100. Let me go here. I don't think my numbers were very good ones, but let's try it. And total revenue at 8 units is going to be 8 times 12, which is 108. So there we go. So we can see that as price goes down, total revenue goes up, which is our very definition of elastic. So in this range of the demand curve, if we do that calculation on any of the values, we're going to find that as long as marginal revenue is greater than zero, if something is being added to the total, we're going to have elastic demand. In the section where marginal revenue is less than zero, it's negative, then you're going to have inelastic demand. And we can, again, use the total revenue test to prove it. And by that, I would say as the price falls or rises, you look at it either way you want, but let's say as price falls, total revenues are also going to fall. And that is because at this definition, right, marginal revenue is negative. It's taking away from the total. So inelastic demand is going to tell us that as price falls, total revenues will fall. So we can see those two features of the demand curve, and it helps us with our understanding. If this curve were perfectly elastic, it wouldn't work because we'd have a vertical curve and there's no ability to show marginal revenue less than the price. So this is why we see it. And hopefully you get lots of chances to see this graph. This is a really important thing to know about how monopoly firms operate. That idea that when marginal revenue is negative or less than zero, it's going to change their output decisions. So this is going to decrease revenues as prices come down, and this is going to increase revenues as prices come down up in this section right here. Number 5 says assume that a pure monopolist and a purely competitive firm have the same unit costs. In this case, determine what is true with respect to price, output, and profits. So we're going to be comparing a monopolist and a perfectly competitive firm. So the first thing that is true is that the price of a monopolist is going to be higher than the price of the competitor. So if you remember the market structure, the monopolist is going to have that downward sloping demand curve, very wavy, and the perfect competitor, the firm, is going to have that perfectly elastic demand curve. So the monopolist is going to produce where, let me put that back, where marginal cost is equal to marginal revenue, profit maximizing output. So let's call this marginal cost. So here's our marginal revenue curve, sits below the demand curve. So the output, the profit maximizing output for the monopolist is going to be at this lower quantity, and the price is going to be at a higher price than the perfectly competitive firm. So the perfectly competitive firm has this flat elastic demand curve. They're going to produce where marginal cost is equal to marginal revenue. And so that's going to be marginal revenue. That's Mr. DARP, if you remember that. And their price is going to be lower. Now you can't see it here, but let me put it on the same graph and it might help to see it. So if the Mr. DARP curve means that marginal revenue is equal to demand, then if we put that into the market with the monopolist, that point, MC equals to D, is right here. So this would be the perfect competitor's price and output. And you can see that their price would be lower and their output would be higher. So that's for the perfect competitor, and the monopolist is here, price and output. So you can see pretty easily the comparison that way, that they face different market situations, but if we assume they have the same costs and that they are still output profit maximizing decision makers, then we can see those two things are true. So 1 and 5 are going to be true. And then the last thing that's true is 7, because by definition, the profit of the monopolist is going to be greater than the profit of the competitor. If they're producing, let's assume this is average total cost as well, they're at zero economic profits for the perfect competitor. They're producing at the price that it costs them to sell, right? Marginal cost is equal to the price in the marketplace, demand. So they're going to be breaking even, whereas the monopolist is going to have positive economic profits equal to the distance between this. And I didn't put average total cost on our graph, but we can see pretty easily that that's going to be a positive economic profit if it's above average total cost. And we're assuming that they have the same average total cost figure. So A says which of the combinations above are accurate. So we're just going to find that combination. Part B, for number 5, says that assume that a pure monopolist and a purely competitive firm have the same unit costs. Same as before. In the case of the monopolist, how are resources going to be allocated? And we know that it's going to be inefficient. If you remember what we just saw before, the socially optimal or perfect competitor's output is going to be efficient. It's going to be efficient. Let's assume that this is production at lowest average total cost. So in this case, we would have efficiency. So the monopolist, by definition, is going to be an inefficient producer. The outcome is going to be inefficient. And it's because the monopolist does not produce at the point of minimum ATC. So let's see, inefficient right here, because a monopolist doesn't produce and does not equate price and marginal cost. Again, go back to this. And for the perfect competitor, price found on the demand curve, because that's what people are willing to pay, is equal to the marginal cost. So for the perfect competitor, that's true. However, for the monopolist, they are, by definition, inefficient. They restrict output and bring the price up to what the market will bear at that output level. C, even though both monopolist and competitive firms follow the MC equals MR rule in maximizing profits, there are differences in the economic outcomes because pure competitors, by definition again, are small and they don't have market power to affect the change of prices. D, the cost of a purely competitive firm and monopoly may be different because monopolies might experience some economies of scale not available to competitive firms. You see this in larger operations where they are able to produce at lower per unit costs because of these economies of scale. Those are often not available to competitive firms. E, if a monopoly can experience economies of scale, then it might reduce the price below, it can reduce the price below a pure competitor and improve resource allocation. So here it is. It's not always easy to spot the right answer. Number 6, U.S. pharmaceutical companies charge different prices for prescription drugs to buyers in different nations, depending on the elasticity of demand and government-imposed price ceilings. U.S. pharmaceutical companies, for profit reasons, oppose laws allowing reimportation of drugs to the United States because reimportation would do what? It would make it much more difficult to maintain the differing prices. They could not engage in that same level of price discrimination that occurs when they are selling it to different nations. Number 7, in the diagram below, the demand, marginal revenue, average total cost, and marginal cost curves are given. Identify the monopoly price, the fair return price, and the socially optimal price. This is an excellent opportunity to make sure that you can see this graphically and find all of those values. So the monopolist price, let's start at MR equals MC. So we're going to go right there. And let me use a different color. It's a little harder to see. So we're going to start with that output decision. We're going to bring output here. And you'll put this on your graph with the snap-in tools that happen to exist there. Then we're going to carry this output level up to the demand curve. They're going to sell it for what people are willing to pay at that output level. And so that's going to be the price of the monopolist and the quantity output of the monopolist. Then it says find, let's see, what am I looking at next? Oh, for the fair return and the optimal. So socially optimal then, I'll use a different color for that. Let's see if that works better. Is where marginal cost, socially optimal, is equal to where marginal cost is equal to demand. So we're going to find marginal cost equal to demand right here. And the socially optimal price then is going to be carried over here because it's already touching the demand curve. And the quantity socially optimal will be here. And then finally, let's find our fair return. And that is where demand is equal to average total cost. So the fair return price is going to go where we can find the demand curve and we can find average total cost, where those come together right here. And so we're going to carry that over in the fair return price and the quantity fair return. So that's a really good way to understand this graphical representation. Understand the monopolist's price and output is based on that profit maximizing quantity and carried up to the demand curve for price, and the output is at that profit maximizing point. Fair return is where demand is equal to ATC, and socially optimal is where MC is equal to D. Number 8, refer to the demand schedule below. Use the demand schedule to calculate total revenue and marginal revenue at each quantity. So this is going to be pretty straightforward, and then it's going to ask us to use it in a graphical context. So we're going to just do the calculations. If you remember what total revenue is, price times quantity is total revenue, and marginal is the change in total revenue divided by the change in quantity, which is going to be 1 in every case. So we're going to just use the change in total revenue. So total revenue here is 0, and then 650. The change is 650, and so on and so forth. So 2 times 6 is going to be 12, and the difference there is going to be 550. Let's see how many of these I can just quickly jot down. Let's see, 1650, and the change is 450. Hopefully this is readable. Then we've got $20 and $22.50, and our marginal amounts are, let's see, 350 and 250. Hopefully that's as much as I'm going to need here. And let's go yeah, I think we can stop there. Plot the demand, total revenue, and marginal revenue curves. So I can take a minute here and put in the rest of these values super quick. $24, but I think you get the idea. I'm hoping that you'll be okay just putting this data into the graph. So it says plot total revenue curve. So you're going to take the information here, and price goes on the vertical axis. So total revenue and price are measured here, and it's going to be related to the quantity. So if we plot our total revenue curve, we're going to do it based on the relationship between quantity and total revenue. So for the first one, we could do, one, the quantity of 1 is going to have total revenue of $6.50, and you're just going to plot these points. 2 has total revenue of 12, and so on and so forth. And you'll see the curve, and I don't want to mislead you too much, but it's going to have approximately a shape of this. Okay, it's going to increase at an increasing rate for a while, then it's going to flatten. You've heard that curve or that phrase recently, flattening the curve. As the rate of increase slows, then it's going to reach a maximum, and then as total revenue starts to fall, that's where we are experiencing negative marginal revenue. Marginal revenue is another thing that we're going to plot, again, using these points. So marginal revenue relative to quantity. So for 1 unit, it's $6.50, and I'm really just sketching it here, so watch out for how you're putting it in your graph. Then 2 units starts to fall already, $5.50. 3 units, $4.50, and so on. So I'm really sketching it out roughly here, but you're going to see the marginal revenue curve fall. By the time we get to 6 units, we're at $1.50. We're down here. And I actually don't know when it goes negative. Let me just keep going here. $1.50.5. I want to put it just a little more data here so we can see it. 20, 50. Then we have $24.50. I see what we're doing. And then we get to the point where we have $24 in total revenue, and so we have a negative marginal revenue. So at 8 units, you can see that it's going to go into the negative. So it's actually going to cross this axis and become a negative value. Then we are asked to put in the demand curve. And the demand curve is going to just be price and quantity, just like we've seen a lot before. So we can put that value in. And again, we're just kind of going to go off of this. The price of $7, nobody wants this. And $6.50, 1 unit, and so on and so forth. $6, 2 units, and I'll try to clean this up a little bit. But you're going to get a demand curve that actually sits, it kind of mirrors the first one and sits about like this. It has a downward slope to it. I didn't sketch it very well there, but when you put your values in, you'll see how it works. So after we've plotted that, C says, suppose the marginal cost of successive units of output was 0. What output would the profit-seeking firm produce? And assume that they can only produce whole units. So how many units are they going to do if the marginal cost of successive outputs is 0? So marginal cost equals marginal revenue. That's our profit maximizing output decision. So if marginal cost is equal to 0, then how many units are they going to produce? They're going to go to 7, and here's why. Because after they produce the 7th unit, they're breaking even, but they're still in a positive situation, right? Marginal cost is still greater than marginal revenue. If they produce that 8th unit, they're actually losing revenue. It's a negative marginal revenue, which means that their total revenues begin to fall, and they're not going to want to produce. So suppose this unit, assume what profit would, output rather, would the profit-seeking firm produce? That's going to be 7 units. They're going to stop where marginal cost is equal to 0 and where marginal revenue, right? MC equals MR. And so it'd come between those two values, 0. And there you have it. Number 9, what types of industries should be subjected to industrial regulation? So number 9 says that it's talking about natural monopolies here. Industrial regulation, natural monopolies are usually subject to this because they're allowed to exist. They're beneficial to the economy in many ways. A natural monopoly is something like a power company, where they can utilize economies of scale. They can produce a lot of something at a lower per unit cost than a smaller firm would be able to produce it at. And as a result, they are often regulated by the government to make sure that they don't take advantage of their monopoly power and raise prices. Industrial regulation, then, can create disincentives to minimize costs and diminish the competitiveness of the industry. That's one of the challenges of regulation, is you don't want to regulate at such a low cost that the discouragement is there. You don't want to regulate to the point where they have no reason to invest in further infrastructure. And also you don't want to regulate in such a way that they have no incentive to reduce their costs. So big challenge with industrial regulation. Number 10, Carrot Computers and its competitors purchased touchscreens for their tablet computers from several suppliers. The 6 makers of touchscreens have market shares of respectively 19%, 18%, 14%, 16%, 20%, and 13%. And this is asking us about the Herfindahl Index for the touchscreen manufacturing industry. So the way that we calculate the Herfindahl Index is we are going to take the values of the market share squared to get a total value. So we're going to take 19% squared plus 18% squared plus 14 plus 16 plus 20 plus 13. And we'll take those values, add them together, and that's going to give us a total value, an index value of 1706. B, by how much would a proposed merger between the two smallest touchscreen makers increase the Herfindahl Index? And here, what we're going to do, the two smallest firms make up the 13 and the 14%. So we're going to put those together, and now we're going to calculate them as one firm. So we're going to take 19 squared plus 18 squared plus 27 squared, right? We're going to add those two together, plus 16 squared plus 20 squared, and now we're going to have a change in value that brings us up to 2070. And the increase then can be calculated by taking the difference between them, which is going to be 364. Would the government be likely to challenge that proposed merger? And the answer is they probably would, because an index value above 1800 is considered a market that is too concentrated. So by taking it to the level of 2070, they would probably challenge it, because they tend to look at those mergers very carefully to see if there's too much concentration in an industry. C, if Carrot Computers horizontally merges with its competitor Blueberry Handhelds, by how much would the Herfindahl Index change for the touchscreen industry? And this one is going to be 0, because they have market shares that haven't changed. So therefore the index won't change for the industry because their market shares will simply be the same. Nothing will change. For number 11, we're told that pure monopolists may obtain economic profits in the long run because, and the key here is the long run. So remember that for perfectly competitive firms, positive economic profits can't be sustained in the long run. They're only short run, because in the long run, all inputs are variable and other firms can enter into the market, which brings the market price down and brings a temporarily profitable or a positive economic profit industry into a long run equilibrium. However, the monopolist can sustain long run profits because they keep other firms out. So other firms coming into a competitive market bring the price down and lower profits. Pure monopolists don't have that problem. They have barriers that keep other firms from entering. These are competitive barriers. Sometimes it's geography, sometimes it's laws. There are lots and lots of things that serve as competitive barriers so that other firms don't come in and shift that supply curve. So that's the answer there. The demand curve faced by a pure monopolist is less elastic than the one of a single purely competitive firm. So let's see, is less elastic than that faced. Okay, gotta read that right. Just a quick review of the look of it, and the downward sloping demand curve is what is faced by a monopolist, where for the firm in a perfectly competitive marketplace, they face that perfectly horizontal or perfectly elastic demand curve. Number 13 says, which of the diagrams correctly portrays a non-discriminating pure monopolist demand and marginal revenue curve? So non-discriminating. So we can look at these and say, well, there's a few things that are obvious right off the bat. First of all, this one is incorrect, right? Because marginal revenue is less than demand. For a monopolist, this would not be true because that's for a perfect competitor. And this would be for a perfect price discriminating competitor. So it's not that one. So your answer here is B. And that's what a monopoly firm looks like in terms of its marginal revenue and demand curve structure. Number 14, which of the following which of the diagrams correctly portrays the demand and marginal revenue curves of a pure monopolist that is able to price discriminate by charging each customer his or her willingness to pay? And that's going to be this one, because what happens is marginal revenue is no longer less than demand. For each additional unit, I can charge a different price. If I can be a perfect price discriminating monopolist, then I can charge each participant what they're willing to pay. So you see examples of price discrimination in marketplace where different people pay different prices for the same thing. So for example, senior citizen prices at movies, or people who use coupons in grocery stores. There are lots of examples of this. So it just means that they differentiate their market into different groups, and if they can charge a different group a different price, then that is what we would consider price discriminating. And so what we get at the end of that is a demand curve, meaning price, that is equal to marginal revenue. We get as much revenue when we sell a unit to each individual at what they're willing to pay. Number 15, refer to the data for a non-discriminating. So that's really important because now we're looking at this picture of the monopolist, right? This firm will maximize its profit by producing. So we're going to look at where, remember, marginal revenue is equal to marginal cost. And the marginal revenue here is less than the price. So we know that we're looking at that non-discriminating. And we can just look at where marginal revenue is equal to marginal cost. So we can see at 4 units, marginal revenue is equal to marginal cost. And there's our decision. Number 16, refer to the data for, again, a non-discriminating monopolist. At its profit maximizing output, which we just determined was 4 units, the firm's total cost will be, and so we've got average total cost, 4 units. So we're going to take the average total per unit times the 4 units, and that's going to give us costs of $198. Number 17, refer to the diagram for a pure monopolist. Monopoly price will be, we're going to find MR equal to MC as our output decision. We're going to carry it up to the demand curve over here, and the price is C. The practice of price discrimination is associated with pure monopoly because monopolists have considerable ability to control output and price. They have that ability in the first place. A perfect competitor has 0 impact on price. If they, as a firm, want to try to charge a different price, they're not going to be effective at doing that. But a monopolist, because the monopoly firm is the market, have a significant amount of control over price and output and can access our markets and segment them into ways that they can discriminate. Number 19, if a monopolist engages in price discrimination, it's going to charge a higher price where individual demand is inelastic and a lower price where individual demand is elastic. They're going to, where somebody has very little response, they're going to charge higher prices. That's going to maximize their revenue because we're going to get a higher price. Remember, in inelastic demand, a higher price brings about higher revenues. And where demand is elastic, if they want to increase revenues, they're going to have to lower prices to get total revenue to increase. So this is our definition of our total revenue test: inelastic and elastic. And number 20, our last one, the graphs represent the demand for the use of a local golf course, which there's no significant competition. It has a local monopoly, so geographical monopoly. P denotes the price of a round of golf, and Q is the quantity of rounds sold each day. If the left graph represents the demand during weekdays, and this is weekdays, and the right graph on the weekend demand, then over the course of a full 7-day week, this price discriminating, price maximizing golf course should sell a total of, so this is the weekend, this is the weekdays, and we want to find out how much they sell. So the answer here is 1,200 rounds. So let me kind of walk you backwards through that. So we've got 5 weekdays, right? And 2 weekend days. And we can see they're profit maximizing and price discriminating. So they're charging people different prices on different days. So weekdays versus weekend prices. So we can take 5 days, they're going to produce MR equals MC. That's where we need that information, that they're profit maximizing. So they're going to sell 200 rounds at $7 each. That's going to be 5 days times 200 rounds each, and that's going to be 1,000. On the weekends, they're going to come to marginal revenue equal to marginal cost. They're going to produce 100 rounds at a cost of $10. So they're going to do 2 days times 100 rounds each day and $200. And this is because they're profit maximizing firms. So they use the MR equals MC, but they're also, this same golf course rather, is a price discriminating firm, and they charge different prices on weekdays and weekends. So our total is 1,200 rounds. And I put a dollar sign there. Should not have. It's 1,200 rounds of golf. It's a lot of golf. All right. So that's our look at this concept in this chapter. And I hope you will go through, practice. Whenever you have a concept that's new and challenging, perhaps draw the graph, see it graphically, go through the numbers, see if you can do the calculations, and practice the different versions of the homework problems. And I wish you lots of luck.